It's hosted locally right now. We have used Django, which is a Python based MVC web application framework. The backend scripts are written in Python, and the front end uses HTML, CSS, JavaScript, jQuery, and Bootstrap. So, welcome to our application. Let's go ahead and explore. As you can see, there are three links to D3, Banana, and Facet View. So we'll first go and check out our visualization using D3 and run a few of the scientific queries and see the result. So this is a link to our Django application that creates the D3 visualization. The first query that we have been asked to run is what time-based trends exist for discussion of oil, iron, and other natural resources in the Arctic region? Are documents and topics collocated to geographic regions? We will go ahead and run the query like so. And as you can see, we have 6 visualizations that we have created using D3. We have a world map that plots all the documents based on their latitude and longitude, which in turn was indexed on Solar through Clavin. What we notice that after running the query on D3, our time series map, which is over here, a time series map plots all the documents based on their timestamp. The x-axis is the year and the y-axis is the time of the day. We also have a force graph. The force graph actually clusters the documents based on their latitude and longitudinal data. All the documents within 1,000 kilometers of each other are bunched together. So as you can see, we see 3 distinct clusters here. So the clustering is of course based on the geographical parameters, and so you see that documents that are closer to each other are bunched together. The color coding is such that the color blue refers to the most important documents, the top 10 of our results. Documents 20 to 30 are represented through orange. Documents 30 to 40 are represented through green, and 40 to 50 are red. So the color coding tells us the importance of the documents, and the clustering gives us an idea of how they are bunched together on a geographical scale. So far we have seen the world map, the force graph, and the time chart. As you move across the time chart, you also see that the pointer gives us an indication of both the month, the year, as well as the time of the day. Apart from these three, we have created visualizations using word cloud. Word cloud throws the most prominent of the words that occur in the relevant documents at us. So the bigger the word, the higher is its occurrence in our documents, in our document results basically. We also have a bar chart. The bar chart gives an idea of how big the content is of the relevant results. And finally, we have a pie chart that gives us an idea of the content type of the documents that we get as results for our query. So we use 6 visualizations to represent our results. So we saw that after running the query on D3, our time series map suggests that there has been a gradual increase in the collection of documents related to discussions on oil, iron, and natural resources over the last decade. This might be because of the rise in awareness levels of the harmful impact of mining and extraction on climate change. So yes, to answer our first question, the documents and topics are collocated to geographic regions as has been observed in the world map. and also on the time scale that is observed through the time chart. To answer our second question, it asks how many regions of interest are represented by the data you collected, and we have been asked to identify geographic regions for the same. So let's go ahead and put a star here because we want to see the kind of geographic regions that are charted for all our documents indexed. So now you see that these are the documents that we have indexed, and they represent certain portions of North America, Greenland, Northern Europe, the Arctic Ocean. So the force graph for the same. So we see that most of the documents are concentrated in Northern Europe and Russia. Again, a time series distribution of the documents, and you see that there is a uniform distribution of documents almost. The word cloud for the same, the bar chart, and the pie chart. And over here we see that there is a bigger variance than the previous query in terms of the content type that was returned to us. We also have to answer two more questions, and for this we will use banana and facet view. So let's move ahead to banana. This is our console. As you can see that we have a few documents indexed as it is. So the advantage of banana is that you can talk directly to your Solr and create visualizations very quickly. So we shall run the third query, the third scientific question rather. It asks, can you predict areas in which there are national security interests? Which areas and why? So I will put in the relevant query, which is regions of national security interest. And we see that we get certain results. So it shows the top 10 results from the 647 documents that are available. And here is the visualization for the same. We have information on locations, the date that the documents were created and how they are organized, the last date updated. We also have a frequency histogram over here that gives us an indication of the geographies that are indicated in our documents. As you can see, the Arctic region is by far has a higher occurrence than most other regions. We have a word cloud over here which is similar to the D3 visualization. As you can see, there are fewer words here. So a definite advantage of D3 over this would be that the word cloud throws a lot more words at us, and so we get a better idea of the relevancy of the words to the queries. So to answer the question about national security interests, the Arctic region is a fragile environment and is rich in resources, and as a result of this, it has a direct correlation with the national security interests of all countries that are located close to it. The Arctic region is experiencing an increase in human activity, as a result of which national security interests have grown in the region. So after running the relevant query on banana, we observed that the areas in which the national security interests are high include territories of nations that are either located close to the polar regions or hold an active presence in the same. These areas are mostly Northern Europe, Canada, USA, and Russia, nations that hold a stake in the polar regions. To run the fourth query, we will go to facet view. We have our facet view over here. As you can see, the facets that we have considered are places, scientific terms, latitude, and time range. And we will go ahead and enter our fourth query over here. The fourth query is there a trend with respect to climate science data and measurements related to climate change? Is it time-based or geographic-based? What areas show a high document relevancy for sea ice extent and decline? So this is a two-part question, and the first query would be measuring climate change to answer the first part. And we see that facet view throws a bunch of documents at us. Again, the advantage of using facet view is that it talks to Solar directory, and we don't really have to do any extra development to create these visualizations. Now, if you look at the facets, if you look at places, we see that these documents are organized according to the geography, the places in a decreasing order. So you can also see the region that occurs the most. We also see that it is organized as per the scientific terms, which is also indexed on Solar. The third facet is latitude, and we see the documents categorized based on their location, namely latitude. And finally, the fourth facet is time range. So we see the documents clustered and categorized based on certain time spans. To answer the second part of the fourth query, it says what areas show a high document relevancy for sea ice extent and decline. So we will go ahead and enter that and watch facet view as it throws the relevant documents at us. And when you go through the facets, you again see that the documents are organized along those lines. So to answer the question, with the increase in scientific activities that try to measure the impact of climate change on the polar regions, we observe a growth in the frequency of documents related to the same. These documents also appear to be focused around few geographic territories. So yes, there is a trend, and it is both time and geography based. The areas that show a high document relevancy for sea ice extent and decline are predominantly the regions around the south and the north poles. So on a closing note, we'd like to say that we utilized these three tools, D3 Banana and Facet View, to create our visualizations, and we finally find that each has its own advantage and lets us create visualizations that allow us to derive insights into data. Thank you.